Hi everyone, this is Dr. GVR Seshagiri Rao, Professor in the Department of Mechanical Engineering, Institute of Aeronautical Engineering, Hyderabad. So in the previous sessions already we have discussed about engineering tribology subject. In this, we have learned different modules like friction, wear, lubrication and corrosion and engineering materials. And also we have discussed the question bank, tutorial question bank and some definition and terminology also we have discussed. In this session, so I will discuss about corrosion topic. So already we have discussed, but again, so I want to explain briefly about corrosion and also some definitions and terminology also added in this session. So that again, we will see the corrosion introduction and the types of corrosions and then the corrosion properties and the preventing methods we will discuss in this session. So the topic is the corrosion, thin corrosion, dry corrosion and wet corrosion. Two types of corrosions are there. So already you know the corrosion is a material removal process means rust formation. So due to this corrosion, some material will be wasted. So the waste and also some material will be removed from the metal surface. These two corrosion types are dry corrosion and wet corrosion, mostly involved in industries and then our machinery components. So these corrosion depends upon the surface and the type of metal and metal properties and type of environmental condition. So all those things we will discuss here. So first of all, dry corrosion. So what do you mean by dry corrosion? So definition is dry corrosion also known as chemical corrosion. So occurs in the absence of liquid electrolyte. So it typically happens in gaseous environments. So dry corrosion is also known as chemical corrosion. See here. So it is called chemical corrosion. Occurs in the absence of liquid. There is no need of liquid electrolyte. So without electrolyte, the material will be corroded. So it typically happens in gaseous environments. So the mechanism involves direct chemical reactions between the metal and gases in the environment. The common reactions include oxidation, sulfidation and halogenation. So the mechanism involved behind this dry corrosion, direct chemical reactions between the metal and gases. The conditions are typically occurs at high temperatures. No presence of liquid phase electrolyte. So not required any liquid. This type of mechanism is called as dry corrosion. So examples: oxidation of metals at high temperatures in air or oxygen. So oxidation of metals at high temperatures in air or oxygen occurred due to this dry corrosion. The sulfidation in environments containing sulfur gases. So whenever the environment gases containing the sulfur, there will be chances of sulfidation. If oxygen present in environment, that is Oxidation process. Already you know, due to the oxidation process, the corrosion will be happen. And sulfidation due to the sulfur gas, that is called as dry corrosion. Halogenation in the presence of halogen gases. Halogen gases example chlorine. So where the chlorine gas present in the environment, the halogen process will be occurred, and halogenation due to the dry corrosion happen. So then, so it is examples for dry corrosion, the oxidation or sulfidation or halogenation. These are three terms. So one is when the oxygen is present in the air. Second one is sulfur present in the gas, and chlorine. So products, the formation of solid corrosion products such as oxides, sulfates, and halides. These products can form a protective layer. For example, chromium oxide and stainless steel, or or be non-protective. For example, iron oxide and carbon steel can form a protective layer. So formation of solid corrosion products. So due to, so example, chromium oxide formed on a stainless steel metal. Similarly, non-protective iron oxide on carbon steel. So characteristics are usually uniform corrosion across the surface. Corrosion rate can be influenced by temperature, gas composition, and metal properties. So often forms a thin continuous film on the metal surface. The characteristics usually uniform corrosion across the surface. The corrosion rate can be influenced by the temperature. So depends upon the temperature, gas composition, and metal properties. The prevention. Use of high temperature alloys and coatings. So how to prevent the dry corrosion? Use of high temperature. So use high temperature alloys and coatings. Already we have discussed in alloys. Copper alloys, the magnesium alloys, nickel based alloys, titanium alloys. So all these alloys you can prevent this dry corrosion, and coatings also. Environmental control to reduce exposure to reactive gases. So application of protective oxide films. Example, aluminizing and chromizing. These two are oxide films. So whereas in wet corrosion, so according to the wet corrosion definition, it is also known as aqueous or electrochemical corrosion. Occurs in the presence of a liquid electrolyte. So occurs in the presence of liquid electrolyte means typically water. So the mechanism involves electrochemical reactions where metal atoms lose electrons, oxidation, and become metal ions. So whenever the electrochemical reactions occurred or involved, there the atoms lose the oxidation, and the metal ions oxidation will be occur. So due to this oxidation becomes the metal atoms become metal ions. So requires the presence of an electrolyte to facilitate ion and electron transfer. But in previous case, in dry corrosion, there is no need of electrolyte. But here, in wet corrosion, it requires the presence of an electrolyte. To facilitate ion and electron transfer, the formation of anodic and cathodic regions on the metal surface. So the formation of anodic and cathodic regions, the metal surface will be occurred. These two anodic and cathodic regions happen. The conditions are typically occurs at ambient or moderate temperatures. The presence of a liquid phase, water or other electrolytes. Examples: rusting of iron in water, galvanic corrosion between dissimilar metals in an electrolyte. The examples for this the wet corrosion, rusting of iron in water. Suppose if you have left iron material in water, there is a formation of rusting. Why? Because here water act as a electrolyte. In galvanic corrosion between dissimilar metals in an electrolyte. So there galvanizing corrosion will be occur between two dissimilar metals. Pitting corrosion in chloride containing environments. So pitting corrosion occur whenever the chloride present in environment. The products are formation of hydrated corrosion products such as rust, iron oxide and hydroxide. Products can be loosely adherent and non-protective, leading to continuous corrosion. The characteristics are can be uniform or localized, pitting and caravage corrosion. The corrosion rate influenced by factors such as oxygen availability and pH and electrolyte composition and temperature involves electrochemical cells with anodic and cathodic areas. So the corrosion rate influenced by the factors. So oxygen availability and pH availability. So depends upon this electrolyte composition and temperature. So all these factors influence the corrosion rate. How to prevent this wet type of corrosion? Use of corrosion resistant materials and alloys. So application of protective coatings like paint, galvanization, cathodic protection. Cathodic protection methods are sacrificial anodes and impulsed current systems are there. Already we have discussed in the theory part. Use of corrosion inhibitors in the electrolyte. Design considerations to minimize curvature and ensure proper drainage. So use of corrosion resistant materials and alloys, so you can prevent this wet corrosion process. So application of protective coatings, paint and galvanization already we have seen in the protective coating methods. And also use corrosion inhibitors in the electrolyte. Concentration to minimize curvature and ensure proper drainage. Next, pitting corrosion. Pitting corrosion is a localized form of corrosion that results in small but often deep pits on the surface of metals. It can lead to significant damage and failure of structures even if the overall metal loss is minimal. So, even the overall metal loss is minimal, it lead to significant damage and failure. Pitting corrosion is a localized form and often deep and fits on the surface of metals. This is a phenomenon called as pitting corrosion. So, material selection, alloy composition. The criteria is choose materials with alloying elements that enhance fitting resistance. The performance is alloys containing elements like chromium, molybdenum, and nitrogen. Examples: stainless steel offer better resistance. So, example 316 stainless steel with molybdenum is more resistant to pitting than 304 stainless steel. So, the alloy composition also, material selection is very important to avoid this type of corrosion. So, alloy composition also we have to concentrate. So, main criteria is alloy composition, performance, and the examples are 316 stainless steel with molybdenum is more resistant to pitting than 304 stainless. So, microstructure criteria is materials with uniform and performance, fine grains, reduce the initiation sites for fits and provide better overall corrosion resistance. Next one is surface condition. So the important criteria is here smooth, clean surface are less prone to pitting. So performance, you see the polished surface reduce the number of curvatures and sites where fits can initiate. Like this, you can minimize this fitting corrosion. So we have discussed about fitting corrosion. In this, so the environmental conditions also important in this corrosion. It influences the corrosion rate, the chloride concentration. Criteria is use materials resistant to chloride induced fitting in environments with high chloride concentrations. The performance materials with higher fitting resistance equivalent PRE numbers perform better. Examples are titanium and nickel based alloys in seawater environments. So already we have discussed about the titanium and nickel based alloys in seawater environments. So these conditions also depends this influence the corrosion rate and at pH levels. So the criteria is consider the pH of the environment where the material will be used and performance. Metals like aluminum are more prone to fitting in acidic or alkaline environments. The temperature criteria is higher temperatures can accelerate fitting corrosion. Select materials accordingly. So before selection, you need to study the temperatures. So why? Because the high temperatures can accelerate this fitting corrosion, and also according to this, according to the pH values and temperature, need to select the materials. The performance is high temperature resistant alloys perform better in a hot environments. So next one, design considerations. So what are the design considerations? Avoid curvaceous and stagnant areas. So criteria is designed to minimize crevices, sharp corners, and areas where water can stagnate. So avoid those crevices and stairways at junction spots wherever water can stagnate. So eliminate. So performance is designs that ensure proper drainage and fluid flow reduce the risk of this fitting. So cathodic protection criteria is use cathodic protection in critical applications to prevent fitting. The performance is sacrificial anodes or impressed current systems can protect susceptible metals. Next, protective coatings and treatments. What are the coatings important and treatments are important to prevent the corrosion? The coatings are the main criteria is apply coatings that act as barriers to prevent exposure to corrosive environments. The performance high quality coatings like epoxy, polyurethane, or metal plate. So here, in the protective coatings and treatments methods can control the corrosion. So like high quality coatings like epoxy, polyurethane, or metal plating, galvanization example, provide effective protection. So surface treatments, some heat treatments like passivation to enhance the natural oxide layer. Surface treatments and performance treatments such as electropolishing improve the resistance of stainless steels to fitting. Next, maintenance and monitoring, regular inspections. So, schedule regular inspections to detect early signs of fitting. You can you can minimize the early signs of fitting corrosion by using regular inspections. The performance is early detection allows for timely maintenance and reduce the risk of catastrophic, failure. The monitoring techniques are one is criteria is use techniques like electrochemical noise analysis and fit depth measurement. The performance is advanced monitoring can provide real-time data on fitting progress. So all these points comes under maintenance and monitoring. The corrosion inhibitors. So chemical inhibitors means criteria use corrosion inhibitors in the environment to mitigate a fitting and performance is inhibitors like molybdates and nitrates can reduce the aggressiveness of chloride ions. Anodic protection. This is a corrosion. Anodic protection is a corrosion control method that involves making a metal structure, the anode of an electrochemical cell to maintain it in a passive state. So, what are the advantages? Effective for passive metals. The benefit is highly effective for metals that form a stable passive oxide layer. Example stainless steel and titanium. The explanation of this effective for passive metals and this anodic protection, the anodic protection maintains the metal in a passive state, reducing corrosion rates significantly. These are the advantages of this anodic protection. It is a corrosion control method. So, in this method, the making a metal structure, the anode of an electrochemical cell to maintain it in a passive state. Next, low current requirements. The benefits is requires less electrical current compared to cathodic protection for maintaining passivity. The explanation once passivation is achieved, only a small current is needed to maintain the passive field. the protection in aggressive environments, the benefit is effective in highly aggressive environments where other protection methods may fail. The explanation can protect metals in environments with high acidity and high temperatures or high chloride concentrations. Next, cost effective for large structures. The benefit is more cost effective for protecting large structures like storage tanks and pipelines. So, explanation lower current requirements translate to reduced energy cost over time. So, similarly, long term protection provides long term protection with minimal maintenance once the system is properly set up. So, there is not required frequently change the components and frequent regular maintenance. It provides long term protection. So, explanation stable passive film requires less frequent monitoring and adjustment. Just what are the disadvantages? Complexity of control systems. Drawback is requires sophisticated control systems to maintain the correct potential. Explanation precise control of the anodic potential is critical to avoid over or under protection. These are the disadvantages. The major disadvantage is complexity of control systems. So required a sophisticated control systems to maintain the correct potential. So limited to certain metals. Drawback only applicable to metals that can form a passive oxide layer. So the not effective for metals that do not readily passivate, such as carbon steel, without suitable alloying elements. The initial setup cost. Main drawback is a high initial cost for installation and setup of the aeronautic protection system. Requires investment in control equipment, power sources, and monitoring systems. The potential for passive layer breakdown. Drawback risk of passive layer breakdown under fluctuating environmental conditions. So, explanation changes in temperature and pH value or chloride concentration can disturb the passive layer leading to localized corrosion. So, the limited use in non-stationary structures. So, the main drawback not suitable for moving or transportable structures. So, not transportable structures, not suitable. So, aeronautic protection systems are designed for stationary setups where constant monitoring and control are feasible. Next one is some definitions and terminology of corrosion also added in this session. So once again we will see some important topics definitions. Up to now we have seen here in this the first part we have learned what we have discussed. Once again we will see the topic is dry corrosion and wet corrosion. So definition and mechanism we have learned, and similarly examples, and then characteristics and prevention methods also we have discussed. Similarly, wet corrosion, definition, mechanism, and then conditions, and products and characteristics, and prevention method. The preventing methods also we have studied, and heating corrosion. So what is heating corrosion, and then how to select material to avoid this the fitting corrosion. And examples also we have studied. And microstructure and surface condition and environmental conditions. What are the conditions influence the corrosion? pH levels, performance, temperature. So all these things we have discussed. And some design considerations also we have learned how to avoid curves and stagnant areas, and similarly how to avoid this cathodic protection. Sorry, how to avoid this corrosion by using cathodic protection. So similarly, protecting coatings. So coatings also can minimize the corrosion, and treatments. Some surface treatments. Use treatments like passivation to enhance the natural oxide layer, and then maintenance and monitoring, regular inspections, and monitoring techniques. So use techniques like electrochemical noise analysis and fit depth measurements. The corrosion inhibitors, chemical inhibitors, and performance also we have seen. Next important thing is anodic protection. So the anodic protection definition, and then this method advantages, and what are the advantages discussed here, like effective for passive metals, and then low current requirements, and protection in aggressive environments, cost effective for large structures, long term protection methods, and disadvantages also there. So disadvantages also we have discussed, complexity of control systems, so limited to certain metals, and initial setup cost, and then potential for passive layer breakdown. And also we have discussed about limited use in non-stationary structures. So now we will see the important definition and terminology related to this corrosion. The important term is in corrosion topic, define corrosion. Sometimes in examination they will ask, what do you mean by corrosion? So any process of deterioration and the consequent loss of solid metallic materials through an unwanted chemical or electrochemical attack by its environment. So this is not required, unwanted. So unwanted chemical or electrochemical attack. So sometimes desirable and not desirable. So starting at its surface is called corrosion. That process of deterioration. Due to this deterioration, material will be lost. From solid particles will be removed from the surface. Which type of metal oxide film cause rapid and continuous corrosion? So, which types of metal oxide film cause rapid and continuous corrosion? The volatile oxide layer volatilizes as soon as it is formed, thereby leaving the underlying metal surface exposed for further attack. So this causes rapid and continuous corrosion. So which types of metal oxide film prevents corrosion? The metal oxide film with the fine grained, tightly adhering and impervious oxide film, and highly unstable oxide film. These are the types of metal oxide film prevents the corrosion. So next one is, what is meant by rusting of iron? So it means the atmospheric corrosion of iron leading to the formation of a layer. So whenever the oxygen present in the air, atmospheric air, so oxidation will be occurred. So due to this, the formation of layer or reddish scale and a powder of oxide on the surface, that is called as rusting of iron. So what is dry corrosion? In previous slides, we have discussed a dry corrosion. The corrosion caused by direct chemical action of atmospheric gases, so such as oxygen, halogen with the metal surface, and sulfidation also due to the gases such as oxygen and metal surface and sulfur. This type of corrosion is called as dry corrosion. Next, what is wet corrosion? Just now discussed wet corrosion. A corrosion which occurs when a conducting liquid is in contact with metal. So whenever the metal contact with the liquid like water or electrolyte. So water here acts as electrolyte. So that corrosion is called as wet corrosion. So what is liquid metal corrosion? This corrosion occurs due to chemical action of following liquid metal at high temperatures on solid metal or alloy. So next one is, what is porous metal oxide layer? So it contains pores and cracks, and the atmospheric oxygen has access to the underlying surface of the metal through the pores or cracks of the layer. So thereby corrosion continues until the entire metal is converted to its oxide. This is called as porous metal oxide layer. So what is volatile metal oxide layer? So the oxide layer formed is volatile in nature and evaporates as soon as it is formed, thereby leaving the underlying metal surface exposed for further attack. So this oxide layer form is volatile in nature and evaporates as soon as it is formed. So this type of layer is called as volatile metal oxide layer. Next, what is stable layer? A stable layer is fine grained in structure. Fine grain can get adhered tightly to the parent metal surface. Such a layer will be impervious in nature. So, what is unstable layer? Stable and unstable layer. The oxide layer formed decomposes back into metal and oxygen. You have seen in fitting corrosion, one is stable, another one is unstable. So the oxide layer formed decomposes back into metal and oxygen. So what are the types of theories of corrosion? There are two theories. One is chemical corrosion and electrochemical corrosion. Electricity is required in this electrochemical corrosion. In this chemical corrosion, not required. These two theories are important in corrosion. So write the effects of corrosion. So wastage of metal in the form of its compounds. The valuable metallic properties like conductivity, malleability, ductility, etc. are lost due to the corrosion. So here the effects of corrosion are wastage of metal will be occurred in the form of some metal compounds. The metallic properties like conductivity, malleability, and ductility, etc. are lost due to this corrosion. That's what is cathodic protection. Cathodic protection means it is the protection of the parent metal from corrosion by connecting it with a more active metal like magnesium, zinc, and etc. The production of the parent metal. So, which material you want to be protected? That metal is called as parent metal. So, you want to prevent the parent metal from corrosion. So then it is connected by with a more active metal like magnesium and zinc, etc. This protection method is called as cathodic. So why is coating of zinc and iron is called sacrificial anode? The zinc acts as anode with respect to iron. So zinc is worn away before the iron ends. Zinc is sacrificial instead of iron. The coating of zinc applied on iron surface. Here zinc acts as anode. So what will happen here? So the zinc is worn away before the iron. So the protective layer worn away, the zinc is sacrificial instead of iron. To prevent the iron, the zinc coating is used. So that the zinc is called as sacrificed one. So what is impressed current cathodic protection? An impressed current is applied in opposite direction to nullify the corrosion current and convert the corroding metal from anode to cathode. What is surface coating? Coating of one metal to the surface of another metal to protect from corrosion. So that is the main aim of the surface coating. One metal to the surface of another metal to protect from corrosion. So all these methods are to protect the metal from corrosion. The anodic preventing method, cathodic method, sacrificial anode method, and impressed current cathodic protection. So next definition and terminology. What is metallic coating? The coating of one metal to the surface of another metal to protect from corrosion. Next, what is cathodic coating? The cathodic coatings are obtained by coating a more noble metal or less active metal having higher reduction potential of lower oxidation potential than the base metal. So what is anodic coating? So anodic coatings are obtained by coating a more active metal having reduction potential than the base metal. Next, what is hot dipping? So cathodic coating and anodic coating. These two are prevent the corrosion. So here in this case, in cathodic coating method, lower oxidation potential than the base metal. But in anodic coating, this active metal having lower reduction potential than the base metal. What is hot dipping? The base metal dipped in a molten bath of the coating metal, which is covered by a molten flux layer. In the galvanizing of process, what is galvanizing? What is galvanizing of iron? It is a process of coating iron or steel sheets with a thin coat of zinc to prevent iron from rusting. So mainly you are applying the zinc layer on a iron surface. For what purpose you are doing? You want to prevent the iron surface from rusting. So this process is called galvanizing of iron. So only the process is called Galvanizing. Why? Because the process of coating iron or steel sheets with a thin coat or zinc. The one iron piece metal is dipped into a liquid zinc. That process is galvanizing. That's what is tinning of iron. The process of coating tin over the iron or steel articles to protect them from undergoing corrosion is known as tinning. The steel articles protect them from undergoing corrosion. Next, electroplating. Electroplating is the process of applying a metal coating on the surface of another metal through an deposition process. Write the application of electroplating. This technique is used in industries to produce metallic coatings. In metals, electroplating increases corrosion resistance, chemical attack does not occur, hardness, wear resistance, etc. These are the applications of electroplating. Generally, this technique is used in industries to produce the metal coating. So, in metals, what will happen? The electroplating increases the corrosion resistance. So, does not attack chemical attack, and hardness also improve, resistance to and wear resistance. These are the applications of electroplating. So, why do metals corrode? So, what is the mechanism behind this corrosion? The most metals are found in nature are ores, like iron ore. So, the manufacturing process of converting these ores into metals involves the output of energy, input of energy. So, during the corrosion reaction, the energy added in manufacturing is released and the metal is returned to its oxide state. So, in the marine environment, the corrosion process generally takes place in aqueous solutions and is therefore electrochemical in nature. So, that is the reason for metals corrode. So, next, what are the corrosion consequences? So, economic corrosion results in the loss of 8 to 126 billion annually in the US alone. So, this impact is primarily the result of one is downtime and product loss, efficiency loss, contamination, over design safety, and loss of the corrosion. Loss of life corrosion can lead to catastrophic system failures. So, we endanger human life and health. These are the corrosion consequences. So, mainly it will affect on economic. Corrosion results loss of 8 to 126 billion annual in years. The very great loss due to this corrosion. The collapse was attributed to stress corrosion cracking, that is called as SCC. Another example, the fuselage of an airliner in Hawaii rapid open due to the combined action of stress and atmospheric corrosion. These two, the combination of these two, stress and atmospheric corrosion, happened in airlines, fuselage of airliner. So, what are corrosion control methods? So, the corrosion occurs due to the formation of electrochemical cells. In order for the corrosion reaction to occur, 5 things are necessary. If any of these factors are eliminated, the galvanic corrosion will not occur. So, this is the key to the corrosion control. So, the corrosion control, what are corrosion control methods? The cathode has a more positive potential with respect to the anode and is termed more noble with respect to the anode. Electrolyte, the electrically conductive medium in which the anode and cathode reside. Next, fourth one is electrical connection. So in one or two control method is seen, and then fourth point is electrical connection. The anode and the cathode must be electrically connected. So potential difference. A voltage difference must exist between the anode and the cathode. So what is the role of corrosion thermodynamics? The corrosion reactions inevitably involve electron transfer. So for this reason, the reactions may be considered electrochemical in nature. All reactions are electrochemical in nature. So thermodynamics can provide a base for the understanding of the energy changes associated with the corrosion reaction. So this is the role of corrosion thermodynamics. See, the corrosion reactions inevitably involve electron transfer, so that it is considered as a electrochemical in nature. Next, what is the role of corrosion thermodynamics continuation? It can in general predict when corrosion is possible. So thermodynamics cannot predict corrosion rates. The rate at which the reaction proceeds is governed by kinetics. So the Gibbs free energy given by the following equation, I will show you, that provides us a tool with which to predict if a corrosion reaction is thermodynamically possible. If it is positive, the reaction will not proceed. If it is negative, the reaction is possible. You can see in the thermodynamics equation, the thermodynamics subject, the Gibbs free energy equation. How does corrosion occurs? The corrosion may be defined as the destructive phenomena and a chemical or electrochemical which can attack any metal or alloy through reaction by the surrounding environment, and in extreme cases may cause structural failure. The corrosion occurs because of the natural tendency for most metals to return to their natural state. Example, iron in the presence of moist air will revert to its natural state. So this is the corrosion occurs, the natural tendency for most metals to return to their natural state. What is importance of corrosion studies? So why should we learn these corrosion studies? So the first is economic, including the reduction of material losses resulting from the wasting away or sudden failure of piping, tanks, metal components of machines, ships, hulls, marine and structures, etc. The second is conservation, applied primarily to metal resources, the world's supply of which is limited and the wastage of which includes corresponding losses of energy and water resources accompanying the production and fabrication of metal structures. So these are the importance of corrosion studies. Next, what are the environmental factors for corrosion? So the factors mainly the normal atmospheric temperatures, the moisture in the air is enough to start the corrosive action. So moisture in the air. The oxygen is essential for corrosion to occur in water at ambient temperatures. So other factors are, one is acidity or alkalinity of the conductive medium, that is pH factor. Stability of the corrosion products. Third one is the stability already we have seen in the previous slides. Biological organisms, particularly anaerobic bacteria. So variation in the composition of the corrosive medium and temperature. So the corrosion problems at KSC is complex. So the presence of salts and acids on metal surfaces greatly increases the electrical conductivity of any moisture present and accelerates corrosion. So moisture tends to collect on dirt particles. So list out the classification of corrosion. So already we have seen in the first slide. The corrosion classified in many ways as low temperature and high temperature corrosion. So direct oxidation and electrochemical corrosion. Chemical and electrochemical. The preferred classification is one is dry or chemical corrosion or wet or electrical chemical corrosion. These two already have seen in first slide. Next, what is fitting corrosion? This fitting corrosion also we have studied. It's important problem that at the root of many corrosion failures. In fitting corrosion, what will happen? The surface of the metal is attacked in small localized areas. Organisms in water or breaks in a passive field can initiate corrosion. So in fitting corrosion, very little metal is removed from the surface, but the effect is marked. So what is intergranular corrosion? The corrosion occurs at the grain boundaries due to the difference in potential between the anodic grain boundaries and the cathodic grains, that is sensitized stainless steels, where carbides have been precipitated in the grain boundaries during improper heat treatment or in the heat affected zone of the weld are particularly susceptible to intergranular corrosion. Next, what is Carvise corrosion? The Carvise corrosion occurs when there is difference in ion or oxygen. So that is concentration between the metal and its surroundings. So oxygen starvation in an electrolyte at the bottom of a sharp V section will set up an anodic site in the metal that then corrodes rapidly. Occurs when there is a difference in ion or oxygen. This is Carvise corrosion. So that is concentration between the metal and its surroundings. Generally occur at this type of corrosion, Carvise corrosion in bolted joints. So wherever the bottom sharp V section available, there it will be happen. So these are the important terms and definitions related to this corrosion. So in this definition terminology, we have studied Carvise corrosion, intergranular corrosion, and fitting corrosion, and the classification also we have seen. And environmental factors for corrosion. So all these are some short answer questions. So in examination they will ask like this. So what do you mean by corrosion and what is the importance of corrosion studies? How does corrosion occurs? And what is the role of corrosion in thermodynamics? Clear? What is the role of corrosion in thermodynamics? And then what are corrosion control methods? You simply have to give answer in so 3 or 4 lines only. No need to explain briefly. Already you have given in essay questions the control methods. So with the help of sketches, there you can elaborate. But in this, briefly need to give the suppose example, what are corrosion consequence, why do metals corrode, and what is the tinning of iron. Only two or three sentences only. See, in tinning of iron, two lines are there. In the world, what is electroplating? Only three. So no need to give full explanation and methods. What he has asked only electroplating definition. So it is a process of applying a metal coating on the surface of another metal through an electrodeposition process only. Clear? So write the applications of electroplating, or just 2 or 1 marks they will ask in examination. So what is cathodic coating, and then anodic coating, dipping, hot dipping, galvanizing. So suppose here what is galvanizing of iron given. So it is nothing but process of coating iron or steel sheets with a thin coat of zinc. So no need to give total entire procedure of galvanizing. Clear? And then cathodic protection, impressed current cathodic protection, the surface coating methods. So many coating methods are there. Just give uh, 1 or 2 lines only answer to this question. Surface coating. So what do you mean by metallic coating? Clear? And then what is stable layer, unstable layer? So what are the types of theories of corrosion? So you see, theories of, he has asked what are the types of theories. So two theories are there. One is chemical corrosion theory and electrochemical corrosion theory. That's all. So no need to give brief discussion about it. So whenever asked, so explain briefly about chemical corrosion theory with the help of neat sketch. So then you need to give full answer. Clear? So wet corrosion and liquid metal corrosion, volatile metal oxide layer, and types of metal oxide film cause rapid continuous corrosion. So all these things we have studied. So this material is more than sufficient. So for corrosion topic. So what is dry corrosion? Definition of corrosion. So all these things we have seen in definition and terminology. So for this PPT, I have taken the references like this. So if you want, you can refer any textbook and for further more information. And also online materials also available. You can go through our website or any Google site. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.